Good morning, students. Welcome in next lecture of Math F211, Mathematics 3. So presently we are studying section 17. So last time we have covered Euler's equidimensional differential equation or Euler's equation x square y double dash plus px y dash plus qy is equal to 0. For that I have told you that convert we transform the independent variable from x to z using the substitution x is equal to e to power z or z is equal to ln of x. So when we compute the dy by dx and d2 by dx2, and when we put our Euler's equation change into second order differential equation with constant coefficient. So that is the after that substitution we have the following equation. And from the basic of the section 17, you know how to determine the solution of this equation. So in last class we have done this. So here let us start from this question. So solve x square y double dash plus 3xy dash plus 10y is equal to 0. So here if you compare with the standard equation, so it will become the x square y double dash plus px y dash plus qy is equal to 0. So it is nothing, it is the Euler's equation where p is equal to 3, q is equal to 10. They are the constant. So for that equation I have told you we substitute x is equal to e to power z to transform independent variable from x to z. So this will give you z is equal to log x. So now when we compute the dy by dx, so dy by dx will come uh, x into dy by dx will come the dy by dz, and x square d2y upon dz2 will come d2y upon dz2 minus dy by dz. So in last class I have given you this derivative. So here this is the value of the d2y upon dx2 or x square d2y upon dx2, right, plus 3 into x into y dash is equal to the dy by dz plus 10y. So it will give you d2y upon dz2 plus 2 dy by dz plus 10y. Means either you write the directly d2y upon dz2 plus p minus 1 dy by dz plus q y is equal to 0, because you know the derivative, so directly you can write. So here we have now the this is the equation, second order differential equation. So it is the second order differential equation with constant coefficient. So you know very well how to solve this second order differential equation with constant coefficient. For that we put y is equal to e to power mz. So here you will get the auxiliary equation m square plus 2m plus 1 is equal to plus 10 is equal to 0. So this will give you m1 m2 as minus 1 plus minus 3 iota. So this is nothing, this is the complex root. So when we have the complex root for the auxiliary equation, the form of the general solution is e to power ax into c1 cos bx plus c2 sin bx. So here we have written the general solution e to power ax into c1 cos bx plus c2 sin bx. So this can be written as y is equal to e to power minus z c1 cos of 3z plus c2 sin of 3z, and z, you know z is what, ln x. So e to power minus log x c1 of cos of 3 log x plus c2 sin of 3 log x. So e to power minus log x can be written as 1 by x, and 3 log x can be written as log of x cube. So it will become 1 by x c1 cos of log x cube plus c2 sin of log x cube. So that is the solution of given equivalent dimensional Euler's equation. So in general, in exam, you people forgot to resubstitute the value of the z. So it is mandatory because question independent variable is x. So you cannot leave in the z. Now, now question number 6. Question number 6 is the little theory part, right? So theory as well as the numerical question. So here first we discuss the theory. So question number 6. Consider the general homogeneous equation. General homogeneous equation y double dash plus px y dash plus qx y is equal to 0, where p and q are function of x. So by some mean, can we convert this general second order differential equation into the second order differential equation with constant coefficient or not? So if it satisfies the few conditions, then we can convert. So change the independent variable from x to z. Here we convert our transform the independent variable x to z using the function zx, where zx is an unspecified function. We do not know what is the function. In the equidimensional, it was z is equal to ln x. But here we do not know which function will convert the given differential equation, given differential equation into the second order differential equation with constant coefficient. So that first can be transformed in this way, right, into equation with constant coefficient. If what are the condition? If q dash plus 2pq upon q to power 3 by 2 is constant, in which case z is equal to, so in that case z will be the following transformation: integral of root of qx dx will affect the derived result. Means if you use this substitution, and after using this substitution, if this expression is coming constant, then our equation can reduce to second order differential equation with constant coefficients. So let us see the derivation. So it is given to you the second order differential equation y double dash plus px y dash plus qx y is equal to 0. Let the independent variable be changed from x to z using the function zx. So you know that if you have to compute the dy by dx, so dy by dx is what? So here, if you have to compute the dy by dx, so dy by dx can be written as dy by dx, and here we can write dy by dz and dz by dx, because z is the function of x. Here we are saying that z is the function of x. So here we can write the dz by dx easily. Similarly, if you have to compute the d2y upon dx2, so d2y upon dx2 is what? It is the dy by dx of the dy by dx. And what is the dy by dx? What is the dy by dx? It is the dy by dz into dz by dx. So by parts, if you do, so it will become dy dx of dy by dz into dz by dx, derivative of the first one, plus dy by dz, and dy dx of the second one, dz by dx. And this can be written as dy dz, and dz by dx. This we can write, and inside we have the dy by dz, and one dz by dx is already there, plus dy by dz, dy dx of the dz by dx. So what this will become d2y upon dz2, d2y upon dz2 into dz by dx whole square plus dy by dz and d2z upon dx2. So that is the, so our equation is what? Y double dash plus px y dash plus qx y is equal to 0. So for the d2y upon dx2, we can put d2y upon dz2 dz by dx whole square plus dy by dz d2z upon dx2 plus px, right? Px. Now here we have the dy by dx is equal to dy by dz into dz by dx dy by dz into dz by dx plus qx y is equal to 0. So that is the substitution. So here we have, so here we have the d2y upon dx2 as a d2y upon dz2 into dz by dx whole square plus dy by dz into d2z upon dx2. So on substitution, so this is the value of y double dash into px into y dash plus qy is equal to 0. So now we collect the coefficient. We collect the coefficient of dz by dx whole square and dy by dz, and here we compute the qy. So here, so d2y upon dz2 into dz by dx whole square plus d2y upon dx2 plus p dz by dx into dy by dz into dy by dz means we combined these two, dy by dz plus q in plus q into y is equal to 0. So if you divide this equation, if you divide this equation by dz by dx whole square, so this will become d2y upon dz2 plus d2z upon dx2 plus p dz by dx upon dz by dx whole square dy by dz plus q upon dz by dx whole square into y is equal to 0. Now to make the second order differential equation with constant coefficient, we have to make this as a constant and this as a constant. Then we will have d2y upon dz2 plus constant into dy by dz plus constant into y. So you have converted your independent variable from x to z, in second order differential equation with constant coefficient. So let's say this constant is nothing, this is the p1, this constant is nothing, let's say it is the q1. So p1 will be the d2z upon dx2 plus p dz by dx upon dz by dx whole square, and q1 is q upon dz by dx whole square. I am saying that it is nothing, it is the constant, right? It is constant. So here, if it is a constant, so here we have the converted second order or transformed second order differential equation with constant coefficient with independent variable z, right? This is the second order differential equation with constant coefficient and independent variable z. So from
Sir,
here, yes,
sir, if
yes,
z is not given to us and dz by dx is in terms of q1, then how can we assume that q1 is constant?
I'm coming, in that I am coming. So here the p1 and q1 are function of x, but function of x, but they can be converted into the function of z by the relation z is equal to fx. So by equating the q1 to a constant quantity, we see that P1 will also become the constant. Means you have to choose the Q1 as a constant. Q1 as a constant. So with that, what will come? With that, we have the dz by dx whole square is equal to q upon k, or dz by dx is equal to plus minus 1 upon square root of k into square root of q. So when we compute the d2z upon dx2, d2z upon dx2, so derivative of above one, it will give you 1 upon root of k, 1 upon root of k into, now derivative of the root of q, so 1 upon 2 root of q into q dash. So here P1 is what? P1 we have assumed as a d2z upon dx2 plus p into dz by dx upon dz upon dx whole square. So just you put the value of the d2z upon dx2 as 1 upon 2 root k root q into q dash plus p into dz by dx. So dz by dx, from here we have the root of q upon root of k. So p into root of q upon root of k, and whole upon dz by dx whole square q upon k, q upon k. So this will come q dash plus 2pq upon q to power 3 by 2 into some constant. So here this implies that if we have the q1 as a constant, naturally the d2z upon dx2 plus p upon dz p upon p into dz upon dx whole upon dz by dx whole square, or q dash plus 2pq uh, upon q to power 3 by 2 will become the constant. I am saying that if this is the constant, then this will come in the denominator, right, in the denominator. So again it will be the constant. So here the means, if you have such substitution, what the substitution? From here from here if you have the z is equal to integral root of qx with respect to dx, right? After this substitution, if you are getting, the p1 is equal to constant, then only you can apply the this method, otherwise you cannot apply. If with this substitution you are getting this as a constant, then only you can apply this approach, otherwise you cannot apply. For all, means it is not necessary always you have the this type of the substitution. For some question only you have this type of the substitution, not for all. Clear now? Means
Yes.
instead of the hit and trial, we have some methodology to determine the substitution. Might it may work, it may not work. It will work only when the q dash plus 2pq upon q to power 3 by 2 is coming constant, then only it will work, otherwise it will not work. Can I move? So here now we have the d2y upon dz2 plus p1 dy by dz plus q1 y is equal to 0 can be solved, only when this is p1 is equal to q dash plus 2pq upon q to power 3 by 2 is constant, and this constant will come after taking the substitution z is equal to integral root of q dx. Then only we can
Sir,
solve
in,
the
sir, in
yeah.
P1, there should be also into root k by 2.
Not necessary root k by 2, whatever here we have na root k by 2. So that 2 will come here and that root k will come here, right? So here we have the root k, here we have the 2, so again it will be the constant, so they will not affect the solution. Let us take the example, then it will clear. So the in continuation of the problem 6, based on problem 6, whether the following equation can be, means not all, right, can be transformed into an equation with constant coefficient by changing the independent variable. Even whatever you have already done, Euler's equidimensional differential equation, that also you can check with this. With that, automatically Z will come ln x. Whatever the theory I have given you earlier, that you can check from here, and that will give you the substitution Z is equal to ln x. So here we have the equation x y double dash plus x square minus 1 y dash plus x cube y is equal to 0. So always before proceeding for the methodology, right, always write the equation in the standard form, because whatever the theory we are developing, that is for the standard form. So standard form is what? Y double dash plus p into x, px, not p into x, px into y dash plus qx into y. So when we write in the standard form, here the px will come x square minus 1 upon x, qx will come x square. Clear? So now we choose z such that dz by dx whole square is equal to q, right? Constant into q, either you say, or only the q. So that will be dz by dx whole square is equal to q, right? In previous, here we have the, right, here we have the. So this will give you dz by dx is equal to x, or z is equal to x square by 2. So this is now the substitution. You have to put the z is equal to x square by 2. Now changing the independent variable from x to z by using the given relation 2. By using the given relation 2, the given equation 1 is transformed into d2y upon d2y upon dz2, d2y upon dz2 plus p1 into dy by dz plus q1 into y is equal to 0, where p1 is what? Where p1 is what? d2z upon dx2 plus p dz by dx upon dz by dx2. So d2z upon dx2, it will be, it is given to you dz by dx, dz by dx is equal to x. So this implies d2z upon dx2 is equal to 1. So here we have written the d2 by dx2 as a 1 into p. P is what? P is given to you x square minus 1 upon x, and dz by dx is what? It is given to you x upon dz by dx whole square is will be the x square. So when we put 1 plus x square minus 1 upon x into x upon whole square, whole upon x square. So here x and x cancel out. So 1 and minus 1 is cancel out. Then x square upon x square will cancel out. So here the p1 will come 1, and 1 is what? 1 is constant. So 1 is what? It is a constant, right? And q1 is what? q1 is q upon dz by dx whole square. So x square upon x square, that is the 1, and this is also constant. So that is the value of the p1 d2z upon dx2 plus p into dz by dx upon dz by dx whole square, and this is the value of the q1 q upon dz by dx whole square. So what is the benefit? You have converted, you have transformed your general second order differential equation into the second order differential equation with constant coefficient, right? d2y upon dz2 plus dy by dz means it is the p1 and it is the q1, and both values are 1. And so now we know the how to solve this. So for this we have to take the solution y is equal to e to power mz, and the auxiliary equation will come m square plus m plus 1 is equal to 0. So m1 comma m2 will come minus 1 plus minus root of 3 iota upon 2. So it is of the form a plus iota a plus minus iota b always exists in the conjugate pair. So in that case the solution will be the y with independent variable z. So it will be the e to power az into cos of bz, c1 cos of bz plus c2 sine of bz, sine of bz. So here y will come e to power az. A is equal to what? Minus 1 by 2. So e to power minus z by 2 into c1 cos of bz. So b is what? Root 3 by 2. So cos of root 3 by 2 z plus c2 sine of root 3 by z. And now this is the solution in terms of independent variable z. So what is the z? Z is, here we have computed z is equal to substitution we have seen. So here we have the z is equal to x square by 2. So when we substitute here, you will get the e to power minus x square by 4 into c1 x c1 into cos of root 3 by 4 x square by 2 plus c2 sine of root 3 by 4, root 3 by 4 into x square, where c1 and c2 are arbitrary constant. So in this case, you can see that we using the z is equal to x square, the given differential equation is transformed to the second order differential equation with constant coefficient. For that, the p1 must be constant. Using the substitution z is equal to x square, p1 must come the constant, where p1 is what? d2z upon dx2 plus p into dz by dx upon dz by dx whole square. So in this we have the another question in question number 6. In that you will find the p1 will not come as a constant, so that you cannot solve by the second order differential equation with constant coefficient, right? In the sixth b part you will find that you cannot convert. Clear? So that is the section 17. Now any doubt up to here? Anything you want to ask? Now next is the method of
Sir, can you repeat?
the method. Yes.
Sir, can you repeat the P1 equation that was initially formed?
d2z upon dx2 plus p into dz by dx whole upon dz by dx whole square.
Okay, sir.
If you want to see the derivation, then here we have the derivation. This is the derivation. So either you check d2z upon dx2 plus p into dz by dx upon dz by dx whole square. Either you check this, or you check q dash plus 2pq upon q to power 3 by 2. Both are the same. So in the book they have means they have directly given this as a constant, right? So you can check anything. Now, the method of undetermined coefficient. So till now we have seen how to solve the homogeneous equation, right? Homogeneous differential equation. Now we are moving to the non-homogeneous part. So let us have the general equation y double dash plus px y dash plus qx y is equal to rx. Now rx is not identically zero, not identically zero means non-homogeneous. It is the non-homogeneous. So for the non-homogeneous, you know by the section 14 theorem A, the solution is what? It is the yx is equal to yg plus yp, where yg is what? Solution, general solution of the homogeneous equation, and yp is what? Particular solution. It is the particular solution of non-homogeneous, particular solution of the non-homogeneous equation. So for the homogeneous equation, we assume Rx as a zero. Rx as a zero. So our equation will become y double dash plus px y dash plus qx y is equal to zero. And for the homogeneous equation, we have studied the following cases. Case first, if px and qx are the constant. If px and qx are constant, let's say px is equal to small p, qx is equal to small q, then in section 17 we have studied that solution we assume as a y is equal to e to power mx as a solution, and depending over the roots of the auxiliary equation, we have the solution either c1 e to power m1x plus c2 e to power m2x, or e to power ax c1 cos bx plus c2 sin bx, or when we have the equal root, then we say e to power mx c1 e to power mx plus c2 x into e to power mx. Then if p and q are not constant, then we can determine the substitution to convert the independent variable from x to z with integral root of q into dx. That is the question number 6 and 7 of the section 17. Then after, if by inspection or by somehow you know one solution, second solution you can determine y2 is equal to vy1, where v is what? Integral 1 upon y1 square e to power minus p dx in with respect to x. That is the section 16. Even if these method will not work, we have the another approach. After this chapter we will start that part, power series method. So we can determine the solution using the power series method. Now we are moving to the non-homogeneous differential equation. So in that first method is the undetermined coefficient. So here procedure to determine the particular solution of complete equation or non-homogeneous equation. So what we have, this is the general equation. Y double dash plus px y dash plus qx y is equal to rx. So rx here is not identically zero. So it can be of any form. Either the rx is of exponential form, e to power mx, ax, e to power bx, whatever the. Or rx can be the sine or cosine trigonometric, or rx can be the polynomial. If rx is of these three type, then we can use the undetermined coefficient. We can have any other also. For example, tan x, cosec x, sec x, anything it can be. But if we have these three function only, then we can use the undetermined coefficient. So we will study one by one all the three function. So first one is the when rx is exponential. When rx is exponential, y double dash plus p y dash plus q y is equal to e to power ax. So you know that if right hand side is exponential, so sum of the exponential can be the exponential only. It means these should also be the exponential. Then exponential is equal to the exponential. So for for the particular solution, we assume that yp is equal to a e to power ax, a into e to power ax, where this a is the same thing, this a is the same thing, and this a we determine have to determine have to determine. That's why its name is the undetermined coefficient. Means here we have to determine the coefficient. So here a is undetermined coefficient, that is to be determined. So from the yp, whatever the particular solution you have assumed, yp is equal to a e to power ax. If you compute the yp double dash, yp dash or yp double dash, so they will come a capital A into small a e to power ax, and capital A into a square e to power ax respectively. So when we substitute, so here we have the yp double dash p into y dash plus q into y is equal to rx. So this will give you a is equal to, if you take the a common, so a into a square plus p a plus q e to power ax is equal to e to power ax. So e to power ax and e to power ax here you can write as a 1. So capital A will come. Capital A will come because we have to determine the value of the undetermined coefficient or of the coefficient. So A will come 1 upon A square plus P A plus Q. On when this will work, then the denominator is non-zero. Right? If the denominator is zero, what is the meaning of the denominator is zero? A square P A plus Q is equal to 0. What is the meaning of the denominator is 0? When the A square plus P A plus Q is equal to 0,
Sir, homogeneous.
not homogeneous, means when this is the root of, when A, when A, when A is root of m square plus mp plus q is equal to 0. And what is this? M square plus mp plus q is equal to 0. What is this? Auxiliary equation, na? In article section 17. This is the auxiliary equation. When a is root of the auxiliary equation, then only a square plus pa plus q is equal to 0. So if the denominator is 0, then capital A in equation number 4 will not work. So to overcome this, we know that if we have the problem somewhere in determining the solution, we multiply with the x. In the section 17 we have seen, if we have the equal roots, so another roots we have determined by multiplying with the x, right? If e to power mx is one solution, so equal and real roots, so another solution will be the x into e to power mx. So taking the motivation from that, we assume that let yp is equal to a into x e to power mx. Earlier we have taken a into e to power mx. Now we are taking the a into x. This x extra we multiply. So from here yp dash will come a e to power ax and plus ax into a e to power ax, and yp double dash will come a e to power ax plus a e to power ax plus ax a square e to power ax. So when we substitute in the given equation, right, y double dash plus pm py or py dash plus qy is equal to e to power ax. If you put So here we have the y double dash, right? Y double dash p into y dash plus q into y is equal to e to power ax. So when we take a ax as a common, inside we have the a square plus pa plus q into e to power ax. Then you take the common a. So inside we have 2a plus p e to power ax is equal to e to power ax. We know that a is nothing, it is the root of the auxiliary equation. Root of the auxiliary equation, this will give you a square plus pa plus q is equal to 0. This will give you a square plus pa plus q is equal to 0, since a is root of the auxiliary equation. So this will give you a into 2a plus p into e to power ax is equal to e to power ax. So this e to power ax and this e to power ax will give you 1. So a will come in that case to 1 upon 2a plus p. Again, if the denominator is equal to 0, so when the denominator is equal to 0, when a is equal to or p is equal to, when p is equal to minus 2a, right? Then, or you can say a is equal to minus p by 2. Then we will say that a you cannot determine, since 1 upon 2a plus p will become the 0. So if it is so, a is root of small a is root of m square plus pm plus q is equal to 0, or a is root of 2m 1 upon 2m plus p, then we cannot use this substitution. Then we have to go another substitution. What is that? Yp is equal to a into x square e to power ax be the solution of the first. Means earlier we have taken the a e to power ax as a solution. If we are facing the problem, then we multiply with the x. Again we are facing the problem, so again we multiply with the x. That approach we are using. So here yp is equal to what? A into x square e to power ax be the solution of the first. So from here we compute the yp dash and yp double dash. So, and after substitution in the given equation, y double dash plus py dash plus qy is equal to e to power ax, and we collect the like terms or coefficients of ax square, ax, and independent of this, or means only a. So here in the bracket we have the a square plus pa plus q, or 2a plus p. So naturally, we are taking this substitution only when a square plus pa plus q is equal to 0 and 2a plus p is equal to 0. Then only we are taking this. So here these two will become the 0, right? These two will be the 0. So when we have this 0, so here you have the 2a e to power ax is equal to e to power ax. So this will give you 1. So capital A will come the 1 by 2. So in that case, capital A value is the 1 by 2. So all the cases we have discussed. So let us have one question over this. So here, any doubt in the theory part? Anything you want to ask? So here we have the y double dash plus 3y dash minus 10y is equal to 6 e to power 4x. So here you can see, if you compare with the standard one, so it will be the y double dash plus py dash plus qy is equal to any constant, you can say c e to power ax, that you are writing. So from here, if you take this as a 0, identically 0, then you will have the homogeneous equation, or reduced equation. So reduced equation is what? Y double dash plus 3y minus 10y is equal to 0. And it is what? It is of what nature? It is the second order differential equation with constant coefficient. With constant coefficient. So the auxiliary equation will come m square plus 3m minus 10 is equal to 0. So m is equal to what? If you take the root, it will come 2n minus 5. So 2n minus 5 means real and distinct. Real and distinct. So in that case, the solution, general solution yg will come c1 e to power 2x plus c2 e to power minus 5x. Now we have to find the particular solution. So for the complete equation, or complete equation is what? This is the complete equation, y double dash plus 3y dash minus 10y is equal to 6 into e to power 4x. So for that, what we have to assume? We assume that let yp is equal to a e to power ax be the solution. It means e to power, since see, this should be in terms of the e to power 4x, this should be in terms of the e to power 4x, and this should be in terms of the e to power 4x. Otherwise left side will not equal to the right side. So here we have assumed yp is equal to a e to power ax be the solution. So yp dash you can compute, and yp double dash you can compute as capital A into small a into e to power ax, and capital A into a square into e to power ax. So now we substitute the value y double dash plus 3y dash plus minus 10y is equal to 6 a e to power 4x. So this will come. So here we put in place of the y double dash, in place of the y double dash we put a capital a square e to power ax, right? A square into e to power ax plus 3y dash. 3y dash. So y dash is what? Y dash is a e to power ax, right? So here we put a into a into a e to power ax. So a you have taken outside, and e to power taken you have outside. So inside we have the 3a. Similarly, when we put the value of the y, so y is what? Y we have assumed as a e to power ax. So a you have taken outside, or e to power ax you have taken outside. So here we have the minus 10 is equal to 6 e to power 4x. So when we left side is equal to right hand side, so we have to write the small a is equal to 4. Then only you can compare. So when we put a is equal to 4, so a is equal to 4, so capital A will come, capital A will come 6, right? Means e to power 4x, e to power 4x will cancel out. So capital A will come 6 upon a square plus 3a minus 10, and a we have assumed as a 4. So it will become 6 upon 6 upon 6 4 square plus 3 into 4 minus 10. So that will be the 6 upon 18, or 1 by 3. So yp will come 1 by 3 e to power 4x. That is the particular solution. That is the particular solution of reduced equation. And you know that solution is what? Y is equal to, general solution of the second order differential equation is what? Yg plus yp. So yg we have computed earlier. So this is your yg plus yp. So now this is the general solution of the second order differential equation. Yes. So that's all from my side for today. If you have to ask anything from whatever I have taught till now.
Sir, if m was 4 instead of 2 or minus 5, then we would directly take the x one, right? Or
If m was 4,
yes, sir. Sir,
huh,
like over there. So we
huh,
could directly check for the 2a plus p and then
huh,
decide
then
which
you can directly check for the 2a plus b.
Yes.
That is another question, next question, but time is almost over, so I'm not taking that. Means here है ना a is equal to -2, here root is -2. So in next class I will continue.
Excuse me, sir.
Yes.
So if we use the second method where we add x to the solution or multiply x to the solution, so the
Huh?
answer still would be same, right? Matlab, if we don't put that value as x, the auxiliary equation, we substitute it as 0, right? So if we don't do that, we'll get the same answer.
You are saying that instead of the yp a e to power ax and yp ax e to power ax, now
Yeah,
what you are doing?
if we use the second one, we'll
Huh?
still get the same answer, right? If
Same
because
answer means exactly same with which?
with the first one,
No, no.
if we
Why
see,
it will
because
come?
we won't in the second method we when a square plus pa plus q, we put it as 0 na. So if we don't
Huh?
put it as 0, then we'll get the same answer.
No, no. That you can. That cannot happen. Na? We are not putting. We are not putting. We automatically due to this value, it is coming 0. We are not putting. For example, in the next here we have the e to power -2x. So auxiliary equation is coming. Auxiliary equation will coming the m is m square plus pm plus q is equal to 0. So that is the m square minus m minus 6 is equal to 0. So in this when we put -2, in this when we put the -2 -6, so automatically it will come the 0. 4 plus 2 minus 6, automatically it will come 0. That's why I'm saying na, here this will become the 0.
Sir,
Clear?
what she's saying is that in the
In next
previous
class,
question.
otherwise I will continue this part. Huh?
Okay, okay, sir.
In next class I will continue this part. Actually I have to do this question na.
Okay, sir. Thank you, sir.
Okay, welcome.